Why the modulus function is used here? Because whenever you get the negative value, because area is always positive. So if I calculate the area of triangle ABC and area of triangle ADC, then sum it up, we will get the total area of the quadrilateral. Suppose if the triangle lies in the negative direction of y-axis, then if A is here, then its coordinate will be 0, minus root 3. Hello my dear students, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we will start a new chapter called Straight Lines. So you have learnt many basics in your coordinate geometry. In today's session, let us recall what we have learnt in coordinate geometry and then we'll connect it to straight lines. In today's session, I'll be discussing all the basics of coordinate geometry which you have learnt in your earlier classes. So let us see what are the formulas related to straight lines and all those basics we have learnt in our previous year. So now we know that distance formula. The very first one is distance formula. So how to find the distance formula of 2 points? Suppose we have 2 points, point A and point B, and they are on the plane, xy plane, origin. If A is of x1, y1 and B is a point x2, y2, then distance of any 2 points is given by AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this distance is measured or is calculated using the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square, where x1, y1, x2, y2 are the coordinates of the points A and B. So along with this, we have learnt a section formula. A section formula gives the coordinates of a point which divides the given line. So how to calculate those coordinates of a point? Suppose we have 2 points A and B, and let me take some point B which is dividing these line AB, this line AB in the ratio m:n, 2 ratios. Okay, the distance between them is considered in terms of ratio, that is m and n. Then how to calculate this coordinates of point P? So again, consider here the coordinates of A as x1, y1 and the coordinates of P as x2, y2. Let me take the coordinates of P as x and y. How to find those formula? Using, that is, P of x, y is given by the formula mx2 plus nx1 divided by m plus n. Similarly, for the coordinates of y, we have the same formula with coordinates of y, my2 plus ny1 divided by m plus n. So this is called as a section formula. Here we have the points which is divided the line AB in the ratio m:n. Suppose if the point exactly divides the line in the middle, that is midpoint, then we take the coordinates of x, y as x1 plus x2 by 2, y1 plus y2 by 2, because the ratio is same. What we call the ratio as m:n. Here, if P is a point, then the ratio between the sides AP and PB are same. That is, the value of m and n is same. So if you replace the value of m and n as 1 in this formula, you will get the midpoint formula as x1 plus x2 by 2, y1 plus y2 by 2. Next, we have area of a triangle. That is, suppose you have 3 coordinates A, B, C, whose coordinates are x1, y1, x2, y2 and x3, y3. Then how to calculate the area of this triangle in coordinate system? That is again using the formula, that is area of triangle is half modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So why the modulus function is used here? Because whenever you get the negative value, because area is always positive. Suppose if you get minus 3 or minus 31 by 2, the value will becomes positive. So therefore, the modulus is used here. So whenever you get the negative answer, make it as positive because it is a area. The measurement is always positive. So we are using the modulus function here. Now, this is the formula to calculate the area of triangle whenever the vertices of the triangle are given in the coordinate system. So the formula is half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Again, the area of a triangle is used in a concept of collinear point. If the area of a triangle is 0, if the value when you are getting calculated, the value when you calculate, if you get it as 0, then we say that point A, B, C are collinear. So collinear means the points are on the same straight line. If A, B, C lie on the same straight line, A, B, C. These are the points which lie on the same straight line. So if they lie on the same straight line, the area will become 0. That is, when you calculate the area of the triangle, if you get the value as 0, then we say A, B, C are not the vertices of triangle because they all lie on the same straight line. They cannot form triangle. Therefore, the area is 0. Hence, we call the points or collinear points. Now, using these basics, let us solve few problems now. We have here a question. Draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5 and minus 4, minus 2. Find its area. So here I have already drawn it using the Cartesian plane. So we have the points B as 0, 7, A as minus 4, 5, D as minus 4, minus 2 and C as 5, minus 5. So here I have taken a diagonal. Why I have taken a diagonal? Because they are asked to find the area. We know any quadrilateral along with its diagonal can be divided into true triangle. So from previous formulas, we know how to calculate the area of a triangle. So if I calculate the area of triangle ABC and area of triangle ADC, then sum it up, we will get the total area of the quadrilateral. So now, using the formula of area of a triangle, I'll calculate area of ABC because I know the vertices of ABC. Now, so area of triangle ABC. So you can take any one as x1, y1, x2, y2, x3, y3. So what is the formula? If I take this as x1, y1, my formula starts with half modulus of x1, that is minus 4 into y2 minus y3. So y2 is 7 minus y3 is minus of minus 5, which becomes plus 5. Next we have x1. After that x2. x2 coordinate 0. So whatever you multiply, it becomes 0. So leave that. Next take x3. So your x3 is 5. Then y1 minus y2. So that is 5 minus 7. So this is the formula. So here we have half. 7 plus 5 is 12. 12 into minus 4 is minus 48. This is 0. And this is 5 minus 7 is minus 2. Minus 2 into 5 is minus 10. So you have here half into modulus of. So minus 58. Since this is modulus, we can make it as 58 divided by 2. So your value is 29. So area of the first triangle is 29. Now let us calculate the area of second triangle, that is ADC. So let me write the coordinates. We have A as minus 4, 5. Next D as minus 4, minus 2. Next C as 5 comma minus 5. So let me take this as x1, y1, x2, y2, x3, y3. Again now area of triangle ADC half into. I'll take this as x1, y2 minus y3, that is minus 2 plus 5. Next x2 is again minus 4, y3 minus y1, minus 5, minus of 5. Next is plus x3 is 5, y1 minus y2, that is 5 plus 5. So this is the formula. So we have minus 4, minus 2 plus 5, minus 4, minus 2 minus 5, 5 plus 5. Now let us calculate the area of triangle ACD. So let us write the coordinates now. So your A is minus 4 comma 5, C is 5 comma minus 5 and D is minus 4 comma minus 2. Let us apply the formula now. So area of triangle ACD, that is half into modulus x1 into y2 minus y3 minus 5 plus 2. Next x2 is 5, y3 is minus 2 minus 5. Next is minus 4, y1 minus y2, that is 5 plus 5. So this is the formula. So now half minus 4 minus 3, 5 minus 7 plus minus 4, 10. So calculate it. 4 3s are 12, 5 7s are 35 minus 40. So you will get it as half minus 63. Remove the modulus. So 63 divided by 2. Now we have got the area of two triangles. The first triangle is 29 and the second triangle is 63 by 2. We will add to find the area of a quadrilateral ABCD. So therefore, area of ABCD is equal to 29 plus 63 by 2, that is equal to 121 by 2 square units. So since this is area, we use the units as square units. So this is how we calculate using the area of triangle formula to find the total area of the quadrilateral. Next we have one more question. The base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Find the vertices of the triangle. So let me write here. We have an equilateral triangle here whose base distance is given. So this is 2A and it is exactly, the midpoint is exactly at the origin. So let me take the coordinates of the point as ABC. Since this is 2A and this triangle is exactly at the midpoint of the origin, so the distance of this will be A and similarly this is A. Since the point C lie on y-axis, since point C lie on x-axis, so this is your x-axis and this is your y-axis, the coordinates of C will be A, 0. And similarly, the coordinate of B on the x-axis, this distance is negative. So this is negative x-axis. So therefore, the coordinate is minus A, 0. Distance is A only, but coordinate is minus A because it lies on the negative x-axis. Now I need to calculate the coordinate of the point A. So this is midpoint. Suppose I take this point as M, or since it lies on origin, I take it as O only. The value is 0. Now I know the vertices of O. This is 0, 0. I know the vertices. So this distance is 2A again. So since it is an equilateral triangle, AB, distance BC and distance AC will be 2A. Now from that we can see the value of B is minus A, 0, that is coordinate, and coordinate of C is a comma 0, because on the x-axis the y value is 0. Now I need to calculate the coordinate of A. How to calculate? Using Pythagoras theorem. So we know that from Pythagoras theorem, what is the diagonal? We have a right angle triangle there, that is AC square will be equal to AB square plus BC square. Okay, but here the second point we have taken it as A. So I'll replace B with O. That is AO square is equal to OC square. Now I know the distance of AC, that is 2A square. Now OA, this distance I don't know, that I need to calculate. OC I know, that is AO square is equal to A square. If I need this, AO square is equal to 4A square minus A square, which is equal to 3A square. Taking square roots on both sides, we will get AO or OA is equal to root 3A, that is plus or minus root 3A. Now since it is on the positive x-axis, so AO is equal to root plus or minus 3 root 3A. So therefore, the distance from here to here we can calculate it as root 3. Now since it lies on the y-axis, the coordinate of this is 0 and the value of y is root 3. So here if we write the triangle on the positive y-axis, it is plus root 3. Suppose they have not given on what side, whether which direction, whether the triangle is in the positive direction of y-axis or in the negative direction of y-axis. Suppose if the triangle lies in the negative direction of y-axis, then if A is here, then its coordinate will be 0, minus root 3. So therefore, the coordinates of A is plus or minus root 3. 0, plus or minus root 3. Why 0? Because on y-axis the value of x is 0 and plus or minus 3 depends on whether it is in the direction of positive y-axis or negative y-axis. So therefore the coordinates of A is 0, plus root 3 or 0, minus root 3. Next we have a question here. Find the distance between Px1, y1, Qx2, y2 when PQ is parallel to the y-axis and PQ is parallel to the x-axis. Suppose let me take a coordinates here. This is your x-axis, this is your y-axis. Suppose PQ is a line parallel to y-axis. So parallel to y-axis means distance formula for this. Suppose if I take PQ or two different points, then the distance formula is given by x2 minus x1 whole square, y2 minus y1 whole square. So now, since if the line is parallel to y-axis, the distance x1 and x2 will be same. That is, suppose if you have P here and Q here, what is the distance here? It is same. That is, the value of x is same. So therefore, for the first question, x1 and x2 are same. If I substitute in this formula, PQ becomes, since x1 and x2 are same, if I replace x1 from x2, it get cancels. So therefore, we will get it as y2 minus y1 whole square, or we can take it as modulus of y2 minus y1. Suppose if you get negative, square and square root get cancels here. Suppose if you get any negative value, make it as positive because it is a distance. Similarly, for the second one, again I will consider the same coordinates, that is x-axis and y-axis. Suppose PQ is a line parallel to x-axis. Then what is this distance? That is distance of y for both the points. So this is your x1, y1 and this is your x2, y2. So the distance from here to here is same as distance from here to here. That is, y value is same. So what we can conclude here, y1 is equal to y2. If I substitute y1 is equal to y2 here, the second equation will become 0. So therefore, your PQ value is square root of x2 minus x1 whole square, which is modulus of x2 minus x1. Why modulus? To make it as positive. Next question. Find a point on the x-axis which is equidistant from the points 7, 6 and 3, 4. So here we have 2 points. One is 7, 6 and 3, 4. Let me take here, I have a point 7, 6 and somewhere here I have a point 3, 4. I have a point which lie on the x-axis. Let me take this point. Let me call it as point P. On x-axis, the value of y is 0. The value of x, I'll take it as a. What they have given here, suppose this is 2 points. Now the distance from P to A is same as distance from P to B. That is, PA is equal to PB. Now using distance formula, since we have 2 points here, they have given, they are equidistant. Equidistance means equal in distance. So therefore, the length of PA is same as the length of PB. Again, using distance formula, let us find the value of A to find the coordinates of point P. Now, square root of, so I can take it as x2 minus x1 means 7 minus a whole square plus 6 minus 0 whole square. Similarly, here square root, I can take 3 minus a whole square plus 4 minus 0 whole square. So, removing square roots on both sides and expanding this, I will get 7 square 49 plus a square minus 14a plus 36. Again, expanding this, I will get this as 9 plus a square minus 6a plus 16. So, I can cancel a square on both sides. So, shifting all a's and constants to either side, I will get the values minus 8a is equal to minus 60. So, a is equal to cancelling minus on both sides, 60 divided by 8. So, a is equal to 15 divided by 2. So, therefore, the point is P of 15 by 2, 0. So, this is the coordinate of the point which is equidistant from the point A as well as point B. So, this is how we calculate all those distances, or we will find the points of a coordinates using the distance formula, section formula, Pythagoras theorem, and this is how we will apply those concepts here. So, in next section, we'll start from the concepts of straight line and how to find the slope and different equations and different various equations to write the general equation of a line. Until then, keep watching, keep learning and keep exploring. Thank you.